So we are going to now see a little more in depth as to how different data structures are accessed. So although we have covered vectors, we'll just get a bit more into that. So let me create a new vector wherein you're saying you're just going to extract the same existing data from Boston, wherein we have already categorized some data. So I'm saying let's use MEDB as data, and you're saying save this as vector. Okay, it's a new vect. Like, you can check the class of this data. It would be a numeric vector, right? You cannot check the dimensions. If you check new underscore vect, it will show you null, because a vector is a single dimension. It doesn't have two dimensions. It's not multi-dimensional. So obviously you cannot see the dimensions. It is just accessed with an index, right? So if I have to access this, I can say new vect. I can refer to some sequence of numbers, show me numbers in that segment. If I want to access a specific element, just say the first element. That's how it would be, right? So this incidentally is nothing but if I have to access the same in the overall object, that's Boston. So I'm saying this first element is nothing but the MEDB value present at the first row, and obviously it's in the 15th column. Okay, that was the second one. So let me say 14th one. So you can say this value, which is referred to in this vector at the first location, is the same one which is present as the 14th column of the first observation. Here you have two dimensions and a vector has just one dimension. That's the basic difference. So if you want to do some temporary function calculation, so when you take data inside a function, you save on space, you make it fast, you might typecast the data from one form, that is in this case the data frame, into a vector form, do your computations, and then come back and save it somewhere else. Now let's do the same thing for the second column, that is the column number 15, which is basically saved in a factor form. So I'm just bringing up the same data which we have kept over here and renaming this into, say, class. That's the intention. And say over here the object, which is my column, class. Now when you check the class type of this vector, it should be a character form as against numeric. But if you remember, when we did the same thing and we applied the same thing in a vector form, say we brought a data, used an if else, saved it into a vector or a matrix, in that case it took a factor form. But when you are taking it from a data frame and bring it back as a vector over here, it takes the basic type as character. If you want to save it as a factor form, you will have to write it. So I can do that over here. As dot factor, or you can do it as a separate step also, or if you want to integrate that in the same patch code, you can do it in this way. So let's try to access this. Say new vect class, try to access, say, location 1 to 5. This is how your data is. Now if I have to say new vect class, overwriting this as dot factor on the overall vector itself, you will just see that the difference is that this double quotes won't come over here. Here it will be in factor form, and this whole stack of data has just two options, low value and high value. If you now try to just convert this back as we had done previously, so if you want to just extract, say I'm just repeating this stuff, as dot numeric, in this case it will give you the number form. So this is how the same thing is saved inside the vector. So this is low as in class, low, high, and this is the actual factor form. Right? So depending upon your usage, you might access this or that. So when you're doing linear regression or logistic regression, you might access the factor. When you want to save it somewhere else and do some other transformation, you might use this form also. Okay, now let's go ahead and access this data frame of yours, and as you can see over here, you had created this crime class also, right? Now you might intend to use it somewhere else with a text form of data also, so you might have to do some more transformations on this data and say let's convert this. So if I want to access only this part of the data, right, so how am I going to access that? How is the structure of a data frame similar or dissimilar to the vector? Incidentally, one single column might be represented as a vector also if you do the typecasting, but in this case I am trying to access this object Boston. So if I say Boston and if I say dimensions, it would be represented as 506 rows and 16 columns. If I want to create an artificial matrix, so I am saying matrix, say new, I am saying let me create a matrix of some numbers, say 1 to 100, and I say the number of rows is equal to 10. So, and if I check the dimension over here, it will have two dimensions, a row dimension and a column dimension. So it's a 10 by 10 because you have said 10 rows, so it has to fix it in that way. If you would change this to say around 1000 elements, and now if you check, obviously dimensions will change, because to manage a data of 1000 elements, if the number of rows is fixed at 10, the column has to be 100. So that's how the dimension comes. So if I have to access this matrix, say matrix new, and I want to access any specific location, I have to specify that, okay, give me the 10th row and the 100th column, give me the value at this location. So that is how it would be. If I say give me the 10th row and the 10th column data, so that's how the address would be referred to. Similarly, when I am subsetting also, I might have to use this dimension or the structure of the data to access a specific data point at a specific location. And the same goes for the data frame also. So for Boston also, but Boston over here is a real data set, so I can access, say, let me give the 506th observation, and I want, say, the 14th column data. Right? So the way a data structure is accessed in terms of dimensionality when it comes to a data frame or a matrix remains the same, but when it comes to vectors, it's a little bit different.